Hi everyone. This video is to talk about the requirement and the algorithm you need for assignment 8. So assignment 8, we will revisit the binary search and rewrite the function become a recursive function. So you can refer to our chapter 20 example 2.cpp file. In example 2, we implement a template function to demonstrate how to do the binary search. So this function is, we have that earlier in the example 2. You can see here we have a binary search template function. We can just pass in the array and the key you're looking for. So then go through this template function because they can be any data type array. So if we find the location for the key, we will return the index. So the index value is not equal to -1. That means we find that the index location. If they return -1, that means we didn't find the key in this array. But in here, actually in the implementation, we're using a do-while loop to do that. Because we always can break down for the binary search, we always start from the middle index looking for that. So then we either go to the first half or second half to continue. So that's why we have the while loop condition is low. If the low index less than equal to high, I just need to continue. But this function we also can implement become a recursive function. So that's why I want you to using this function, this template function, for example, but re-implement that become a recursive binary search function. They are still template function. So the same requirement, this function will receive the array, will receive the key. But we have two more arguments we will receive. That will be the start index and the end index. So if the search key is found, we return the array index. If -1 being returned, that means the key not found. So this example, you don't need to change your main function. Instead, you just add one more recursive binary search function. So then in the main function, you just need to, instead you call the while loop binary search function. We call the new function we implement, we call recursive binary search function. So when they display the information about every element, right, they are still the same. You still can call the display element function. So here is the prototype for your recursive binary search function. So you can see here, we still passing the array, we still passing the key, but we have two more arguments we need to have. Okay, so we just see here, for example, if this recursion function, the array you pass, we call ARR. So that's at the argument, the parameter variable name. Okay, so here, then you have your key. We pass in by reference as well, because we're not sure they are primitive data type or they are an object. So here, the following two value actually is the low index and the high index value. Okay, so how to implement this function? Actually, we need to think about, for example, if I have one array, okay, so the size is 10. So actually, for when we pass in the array, before I just need to pass in the array and pass in the key, right? But now actually instead passing the array only. So here your low equal to 0, your high equal to, you can do 10 or 9. So that's really up to you, depends on how you implement your recursion function. But this recursive function, when we do the binary search, right, all we want to do is actually we pass in the range you want to search in from the array. Okay, so do you agree? Okay, earlier when we talk about recursion, when we do the binary search, if I have 10 elements here, okay, so then if I have 10 elements, actually I don't start from 0, I don't start from 9, I start from the middle of somewhere. Okay, so 0 plus 9 divided by 2. So then we just say we start from the index 5. So index 5 value, I just see here, I'm using parentheses to show you also the index. So if this index 5 is matched, wonderful, we've done. We just return the index. But if this value is smaller than the key we are looking for, so you see here, actually we skip the early first half from the array. We just need to go the second half. If, you see, if the array ARR index, okay, so that's the target index. If this value is less than the key we're looking for, okay, so we go upper half. On the other hand, of course, if greater than, we go to the lower half. So that's why here, actually, when you need to go to the upper half, right? Instead, before we're using a while loop. On the other hand, actually, that's you need to call your recursion function again. Okay, so what you need to do is, before you go to the upper half, when you go to the upper half, actually is you just call the recursion function again. Okay, so your recursion function, you still passing your array. You already have this array from the original function you call. So you still have your key. But here, your high and low, this one actually is your new low and your new high. Okay, so that's here is we call the recursion function. This one I will stop here. I want you to think about how to really implement that by the recursion function. Whenever you try to implement recursion function, okay, so don't forget the first thing, you always need to find your base cases. Okay, find all the possible base cases. Then the second, how to call function again. Okay, so in this example, actually is how to call the function again is according to here. If your array value is less than the key, we go to the upper half. So of course, else if, okay, if they are greater than, then we go to the lower half. On the lower half actually I mean the beginning. Okay. Else actually when you have if not greater, if not less than, so then of course you know not greater than, not less than, that's mean actually if you find the match. Okay, if you find the match, of course, then you just need to return, okay, your index. Okay, so this one actually is the base cases. Okay, however, do you have other base cases or not? So that's a key point how you implement your assignment 8.